In this video, I'll show how to find the derivative of an inverse of a function. Our directions here say that if f of x equals x to the third plus 1, find the derivative of f inverse of x at y equals 9. And typically this is how the problems are asked in this, I think, kind of a convoluted way, where they tell you the y value is like they're playing little games with you, but this is the way it is. And if you take a standardized test, for example, they might not even give you the function f of x. They'll give you the value of its inverse. And so what we'll do is walk through some steps so that no matter what they give you, you will be able to plug some stuff in and find the answer. So the derivative of the inverse. So d dx of f inverse of x evaluated at x equals c. This is the way a lot of books write this x equals c. That equals, so notice that I'm not saying 9 here, I'm saying x, or not y, but x here. But this equals 1 over the derivative of the original function evaluated at the inverse of x, when y equals some value a. I'm just staying consistent with a lot of books. They use a and c here. This y equals a, that's when y equals a in the original, in f of x, not inverse. So when y equals a, then you'll have to solve for the appropriate x then for over here. Okay, and then this c value, this x equals c value, will be what you plug in right here. And I know that this seems kind of weird to write it this way, but I'm staying consistent with a lot of the books, the way they have it written, and this is really what you're doing. You are taking this value of y, finding what the corresponding x is in the original function, and then plugging it into the derivative, of the original function. Okay, so let's walk through the steps here. Let's put them in orange. The first step is find the corresponding x. So when y equals a, find the corresponding x equals c. So in our example, we have y equals 9, and it follows that x equals 2. So that is, if we had 9, this is our y. If this is 9, then we're going to have to plug in 2 for x to make that true, to make that a true statement. So x equals 2, this is what we have. This is our c value. This is what we're going to hold on to for one of our last steps. The next step then is to find the derivative of the original function. Find f prime of x. So in our example, f prime of x equals 3x squared. Nice, we've got it. We've got 3x squared. Now, the next step then is to evaluate f prime of the c value. And that's what we found in our example to be 2. So I'm going to evaluate that, trying to color code the general form in orange and then our example in yellow. So f prime of 2 equals 3 times 2 squared. So order of operations says to square the 2 first and then multiply by 3. So 4 times 3 is 12. Now, this is the magic number that we are going to plug in into that denominator. So in the end, let's write this all the way up. into this denominator, this entire denominator. So in the end, what we have is d dx, the derivative of the inverse function when, or at, x equals 2. That equals 1 over what we've just evaluated here. Let me draw it in the yellow color so we can follow. This entire denominator is 12. So this is our answer for that problem. And don't be discouraged if it feels like you don't understand the concept here. You're just kind of following the mechanics. That happens often, actually, in math, more often than we like to admit. Sometimes you understand the procedure well before you understand conceptually what is happening. That's okay. Ultimately, we want to understand conceptually what is happening, absolutely. But it's okay in the beginning to follow a process, the mechanics here, to get to the desired answer, and then with a lot of practice, the concept comes.